Good morning, everybody. I just want to take the time to go over the test so that you can check your answers and see what you did wrong and what you might have misunderstood. And then the next time we have a Zoom class, you can ask me if you need to. So the first question on the test was 8 to the first power times 8 to the sixth power. So remember, when you're multiplying like bases, you keep the base and you add those exponents. So you get 1 plus 6, and your answer would be 8 to the seventh. Remember, keep the base. We don't multiply the base, so it's not becoming 64. Some of you made a killer's mistake, multiply the 8 times the 8. You do not multiply the base. You keep the base, you add the exponents. All right. The second one, number 2, was r to the fourth power times r to the fifth power times r to the sixth power. So again, if you're looking, all those exponents are on the same level. So that means you're multiplying. And when you multiply, you keep the base, which is r, and you add those exponents. So you're going to add 4 plus 5 plus 6. So you're going to get r to the 15th power. Number 3. Number 3, you have the quantity of negative 3c to the 8th power multiplied by 2c to the 6th d to the 8th power. So we're multiplying. There's no power to a power here. It's all on the same level. So you're going to multiply the coefficients, which are negative 3 times 2. You're going to look and see if there's any like bases, which there are, which is c. So you're going to add those exponents on the c, which is 8 plus 6. Then you have another base, d, but you only have 1. So it's going to just stay d to the 8th power. When you multiply, you get negative 6. Add your exponents, so you get 14, d to the 8th. So negative 6c to the 14th, d to the 8th power. Number 4. Number 4, you have c to the 8th power raised to the 4th power. Well, now you have a power to a power, one exponent on top of another exponent. So now you're going to keep the base, but this time we're going to multiply the exponents. So you should get c to the 32nd power. Number 5. Number 5, you have d times d to the 9th power times d to the 6th power. Again, remember that this d has a 1 on it. Okay, that d has a 1 on it. So when you go to add, you need to make sure you include that. So you keep the base and you add those exponents. So you get for an answer d to the 16th power. Number 6. You have 3c squared times negative 3c squared d squared. So again, you're multiplying. So you multiply the coefficients. You keep the base, which is c. You add the exponents on the two c's. So that's 4, or 2 plus 2. And you get negative 9 c to the fourth power d squared. Number 7. Number 7 is the one that has the most work. Okay, you have different sections that you're going to have to do here. So you have 2q r to the fifth quantity cubed times q r to the sixth power. So you have a power to a power, and you have two of them. Again, remember, first thing you have to remember is that this 2 has a 1, the q has a 1, this q has a 1, and this r has a 1. They all have 1s for exponents. So when you have a power to a power, you keep the base, so keep the base 2, and you multiply the exponents 1 times 3. You keep the base q, and you multiply 1 times 3. You keep the base 5, and you multiply the exponents 5 times 3. Now go to the next parentheses, and you do the same exact thing. Q to the 1 times 6. R to the 1 times 6. Now simplify. So you have 2 cubed, q cubed, r to the 5 times 3 is 15, times 1 times 6 is 6, and 1 times 6 is 6 again. So now if you're looking across, you can see that you have like bases here, so that you're going to be able to simplify this even more. Okay, so you're going to take 2 cubed and get 8. Then you have your q with a 3 exponent and with a 6 exponent. So keep the base, add the exponents. Now you have 2 base r's. Keep the base and add the exponents. So your answer is going to be 8q to the 9th r to the 21st power. That's what we have for that. So now let's go over the next one. So the next one, let me just erase some of these. So again, just to reiterate while I'm erasing some of these, power to a power, we keep the base and we multiply the exponents. When we're multiplying, we keep the base, we add the exponents. And when we're dividing, we keep the base and subtract the exponents. So number 8, we have again another power to a power. Okay, so we have 4, quantity of 4t squared r to the 4th power, quantity cubed. So again, remember that there is a 1 on that 4. So now we're going to keep the base and multiply the exponents, and keep the base t and multiply the exponents, and keep the base r and multiply the exponents. And now when we simplify, we have 4 cubed, t to the 6th power, and r to the 12th power. You have to simplify any exponent less than 5. So 4 times 4 times 4 remember, is 64. So your answer here is 64, t to the 6th, r to the 12th. Number 9. Number 9 is 2v quantity squared. Again, let's remember that the 2 has a 1 and the v has a 1. So when we do a power to a power, we keep the base and we add and we multiply the exponents. We keep the base and we multiply the exponents. So we get 2 squared v squared, which is 4v squared. Some of you squared the 2 but forgot to square the v, and vice versa, squared the v and didn't square the 2. But remember that another way of writing that is 2v times 2v. So that would be 4v squared. Okay. All right, so number 10. Number 10 says x cubed over y to the 8th to the 4th power. So now you have a power to a power. You have exponents inside, you have an exponent outside. So you keep the base, which is x, and you multiply the exponents 3 times 4. You keep the base, which is y, and you multiply the exponents, which would be 8 times 4. That's going to be x to the 12th over y to the 32nd power. There isn't anything you can do to reduce that or simplify that because you have unlike bases. They're not the same. So there's nothing you can do. That's the answer. Number 11 is 3 to the 8th over 3 to the 5th. Now, some of you made this a very complicated problem or more work than necessary and multiplied 3 8 times and multiplied 3 5 times and then reduced. But again, the 3's, remember, are your base. So you keep the base, and when we divide, we subtract exponents. So that would be 3 to the 8 minus 5. 8 minus 5 is 3, so the answer is 3 cubed. And 3 cubed, which is 3 times 3 times 3, is 27. So the answer there was 27. Number 12. Number 12, you have h over 4 quantity cubed. So again, remember that that h has a 1, that 4 has a 1. So now you have a power to a power on the inside, power on the outside. So you keep the base and you multiply the exponents. You keep the base and you multiply the exponents. So your answer would be h cubed over 4 cubed. H cubed, nothing you can do to simplify that, so you keep it the same. And 4 cubed, as we did above, is 64. 13. 13 is the same thing as 11, just a different base. So you have 4 to the 10th power over 4 to the 5th power. So again, you keep the base, you subtract your exponents, and you get 4 to the 5th power. Remember, that's 4 times 4 times 4 times 4 times 4. I'm not going to do it all out, but it's 1,024. Okay, you could do 64 times 16. You know that 3 4s are 64 and 2 4s are 16. So 64 times 16, which gives you 1,024. All right, number 14. Number 14. Let me just get up to the top here. Okay, number 14. So 14 says 5 to the 5th, 5 to the 4th, times 5 to the 5th, equal and over divided by 5 to the 6th power. So you've got two things going on here. In your numerator, you have a multiplication problem, and then overall, you have a division problem because you have a fraction. So when we multiply like bases in the numerator, we're multiplying, we keep that base, and we add the exponents. So that's going to give us 5 to the 9th over 5 to the 6th power. Then we're dividing. So when we divide, we subtract the exponents. So that's going to be 5 to the 9 minus 6. Well, 9 minus 6 is 3. So that's 5 cubed. Lower than 5, so you needed to do it out. 5 cubed is 125. Number 15. Number 15, we have a couple rules going on here. You have a to the negative 11th times a to the negative 11th. Well, we're multiplying. So when we multiply, we keep our base and we add the exponents. When we do that, when we add, we get a, erase that, missed it before. We get a to the negative 22nd power, negative 11 plus negative 11. Now we can't leave a negative exponent as our answer. So it's going to be 1 over a to the positive 22nd, because to get rid of a negative exponent, we take its reciprocal. We take its reciprocal. Number 16. So 16, we have 5 to the 0 power times 5 to the negative 12th. So we're multiplying. Actually, we can remember that 5 to the 0 power, anything to the 0 power is 1. 1 times 5 to the negative 12th power is just 5 to the negative 12th power. But as we saw in number 15, we can't leave a negative exponent as our answer, so we need to take the reciprocal. So that's going to be 5 to the 12th power. 1 over, I should have said, 1 over 5 to the 12th power. Number 17. Number 17 is -5 times 4 to the 0 power. Well, anything to the 0 power is 1, so that becomes -5 times 1. -5 times 1 is -5. Number 18. 18, you have 3a squared b to the -2 c to the -3. So when you see positive and negative exponents, remember, you're going to get a fraction for an answer. So you're going to make your fraction bar, and then you're going to ask yourself if the factor has to move or does it stay where it is. 3 has a positive exponent, so it stays where it is. A squared is going to stay where it is because it has a positive exponent. The b to the -2 has to drop down to the denominator to become positive. You take, remember, it's reciprocals. Okay? And then c is to the -3, so it has to drop down and become positive in the denominator. So number 19, similar, very similar. You have to ask yourself what has to move and what has to stay. The careless mistake that some of you made on 19 was the 7. Remember, the 7 has a 1 on it as an exponent, has an exponent of 1. So that's not negative. So when you draw your fraction bar, that 7 is going to stay right where it is. The a is going to have to move down to become positive, and the b is going to have to move up to become positive. So you flip or take the reciprocal of the a and the b to make them positive exponents. Number 20. I'm going to just do 20 over here. So 7 to the 4th over 7 to the 5th. Remember, the larger exponent is in the denominator, so you can subtract in the denominator and do 7 minus 4. And because there's nothing in the numerator, you need to add a 1 to hold its place. So that's going to be 1 over 5 minus 4 is 1. So 1 over 7. Now, that's one way. You could have also said to yourself, all right, I'm dividing. So when I divide, I subtract exponents. Okay? So you had 7 to the 4th power divided by 7 to the 5th power. So you can take that 7, keep the base, subtract the exponents. So 4 minus 5. Well, when you subtract 5 from 4, you get -1. But remember, you can't leave a negative as your final answer. So you need to take the reciprocal of this and get 1 over 7. So it doesn't matter which way you think of it, you're going to get the same answer. I hope this answers any questions that you had concerning the test. If not, like I said, the next time we Zoom, we can go over any questions that you have.